Hello.
Oh, hello.
Hi, how are you?
I'm good, and you?
Good, good. And it looks like Adama's here. Jen, Hussain, and Jess. Jen.
Finishing up lunch, so I won't say that much right now. And yes, Jen's here too.
All right.
He's just gonna listen. He's not really gonna
All right.
have something to say, but just for like help with some of the other documentation.
Yeah. Okay. Yeah, it's great. Welcome. Yeah. So this is going to be what we're going to do each week throughout GSoC. So we have these open source meetings, and the idea is to do a couple things. One is to update us on your project, so you'll have weekly progress on things, and I'll offer people the opportunity to give an update on what they're doing, and we'll have longer presentations or shorter presentations depending on what people are doing. Then we'll have some feature on something in the open source realm, and then we'll have maybe like Jesse has done some wonderful work on project management topics and other things, so we'll kind of mix it up in those areas. And so that's what we'll be doing. So we'll be doing this each week throughout the summer, as long as we need to work on projects and get updates. All right. There's Himanshu. Hello. Okay, so I know Hussain wants to present some things as progress, so I'll give the floor to Hussain and see what he has.
Hi, thanks. I'm in Starbucks,
Oh,
so
hi.
I appreciate. Um, I hope the background noise isn't too much.
It's fine.
Thank you. Thanks. Maybe I can get a bit closer if you guys can hear. Thank you so much. Yeah. All right. Well, congratulations to all the GSoC participants. I'm not on GSoC, but I'm currently working with Oral on a few different things. We were talking about do some work, including this proposed manuscript, a proposed plan for a manuscript on the ethics of neurostimulation. Excuse me, the ethical considerations of AI-assisted closed-loop stimulation. So neurostimulation, but AI-assisted neurostimulation in particular. So neurostimulation technology used in, say, like the treatment of seizures with a closed-loop device that can record brain activity and designed to reduce seizure activity over time, as it's typically being monitored by humans by trained professionals from psychiatrists, physicians, and researchers. When this technology is leveraged to AI, to what extent or in what ways do these concepts of, say, transparency, interpretability, explainability, excuse me, would they be needed to take into account and operated with the guise of, like, how can we make sure things are regulated? How can we, what sort of ethical concerns might be inherent within these, within the loop? It looks like if anyone wants to get on board with this, we can definitely get it together. So just as a disclaimer straight off the bat, there's no intended conference that I'm submitting this to. There's no intended journal just yet. Nothing like that. So there's no specific end goal in mind. But this can definitely be something that we can leverage for anything that comes up down the line. So we want to present this at, like, I don't know, NeurIPS, I guess maybe SFN, something similar, or just to publish it as it is, put it in bioRxiv and see where things go. So yeah, that's what I wanted to present. Thanks.
Okay, that's great. Thank you for presenting. And I don't know if you wanted to give an update on some of the work you've been doing, aside from that, like some of the projects you've been working on.
Yeah, it looks like some side projects. Yeah.
Yeah.
Yeah. So over the past year, I've also been working really busy at a startup. I can post the link for people who maybe aren't so on board at this educational tech company, Alter Learning. And as a consultant for this startup, I wear many different hats. As a researcher, game developer, educator for this educational technology startup that seeks to create VR games to teach kids about STEM, or I guess STEAM, because we're adding the A of arts and STEM too. Although I personally, on a personal level, I hate that. I think that's so stupid. STEM was supposed to be to differentiate science from the arts and humanities. Why put the A back? Like, that's, can't just go back on that. Sorry. So over the past year, yeah, our company has gone from like almost nothing together to now having a developed product that we are pitching to investors very regularly. We've been collecting offers, collecting funds, and we're seeing where things go before we go public. It's about when, not if. So my role as a consultant, as I said, I wear a lot of different hats. I do research. I'm in charge of getting educational plans, and I also help on the data science, AI, machine learning approach in creating software for recognition across voice, face, and emotion as the kids play these games. Because we actually use that in diagnosis for developmental disorders, autism, ADHD, dyslexia, and a few others too. So we aren't just giving kids games to play. We're actually collecting data to use in diagnosis using the help of AI technology. That's actually this what really sets this apart, and is we all do a lot of different things, and it's been a pretty big roller coaster. People have come off, people have got on board, people have expressed doubts, people have been like, even like my family has been telling me like, Hussain, this is a waste of time, but we're glad things have been coming together recently, and things are really coming to fruition though. So a really great opportunity. On top of that, yeah, I'm happy to keep in touch. But so back to the ethical consideration, the ethics paper itself. Perhaps we could have like a specific meeting at some point to discuss this paper in general. Anyone who wants to get on board, because right now the notes we have written are good, but it would be very helpful if perhaps we could perhaps we could have a solid meeting and people could put their like what they want to contribute to, and we could get really specifically like where we want to go with this, because accountability is going to be the best thing for this. It's hard to just put a paper out there and say who wants to get involved, and people will raise their hands, but it's like, okay, but how many people want to devote the time to contribute regularly? That's what sets thing going to set like a pure idea from putting into practice apart. So yeah, thanks.
Yeah, no problem. Let's see. Jess had a question here. Are there ways to or contribute to the VR game meetings for disabilities group?
Yeah. So right now, um, I mean, okay. The actual company, we work on a very strict contractual basis. So it's not voluntary. It's not even open source. Like even for me to get involved in like a software development, the AI machine learning components, I had to go through a very rigorous technical assessment to test my skills, for example. Yeah. On top of that, we have NDAs as well. So while you're always welcome to discuss with our CEO if he wants to get involved in the company, there's some very specific, like I'm under NDA. I'm under NDA for some stuff. Okay. Like but from a more like, I don't know, broad perspective, we're always looking to people to advertise, to maybe test things out, to network to other opportunities. Like I regularly meet with VCs, like entrepreneurs and capital, like venture capitalists, and I meet with them one on one. I meet with them with my company, and we always discuss potentially other offers and other opportunities moving forward. But the work I've been discussing with Oral has been intersecting with what I've been doing with the VR group. Like for one thing, Morgan like several months ago posted a paper on how babies learn language, and specifically which parts of the brain are being involved in that process when language acquisition forms. And I was using that directly in the formation of the game plans when we're teaching kids like speech and voice and language and stuff. So like some of the work we've been discussing here through ORL has been, it's there. You gotta trust that. But yes, Jesse, I do just want to emphasize you're more than welcome to contact the CEO or just contact me. But there are some specific things in place. We just have to make sure of this. So yeah. So the ethical considerations of closed loop stimulation, um, because there are just so many different directions we can take with this paper. We do need to get people together and see what people want to join and work with, and see where things go. So yeah. Ultimately, we're more so going to focus on the literature review, but we can incorporate data, we can incorporate some graphs, some analysis here. So we probably need to. Yeah. Thanks.
Yeah, no problem. So yeah, that's great. Thank you, Hussain, for that update. There are a number of things that you can. That's what we always do in these meetings: is things that you can sort of get involved with. So if you're interested in any sort of open source participation, this is the way to do it. Do we have any other updates, people?
So yeah, I can go next.
Okay.
So my kind of wrote a blog about, as I mentioned, I spent the past week doing some literature review. So there was one paper that was shared by Morgan after my last presentation. So that was one paper, and two other papers that I had also mentioned in my proposal. Kind of made a blog about it, and I could screen share it. It's currently hosted like on my local deployment only. And I also wanted to ask, like, so I do have a website where I used to put my old blogs.
Okay.
So I could I wanted to ask, because I do remember that last time there was some talk about using the group's Medium page. So I wanted to ask about if it would be possible, should I maybe post it on both these places, or should I only stick to posting on the Medium page? Like the link I've shared currently is the website I used to post my blogs on. So
yeah, please cross post them if possible. Yeah, that's always good to do. And yeah, Hussain says use Substack, but the GitHub IO is perfectly fine. Did you want to share your screen, or did you want me to open up the link? Okay.
Yeah, sure. I can just share my screen. I'll give a quick run through of it, and once it's posted, I guess you all can go through it as well.
Yeah.
Just a second.
There we go.
Yeah, so this is the one I wrote. So basically, I do remember that my approach is the work that has been done on open source sustainability previously has been a lot on reinforcement learning, and even the paper that was shared had a complete reinforcement learning approach. And my approach is going to large language models. So the main reason for me reading this paper was to kind of understand how the two approaches, what is common between them and how they kind of correlate. So I can just give a quick run through. The beginning is just an introduction. It's about why we need multi-agent systems, and the main goal of multi-agent systems being to coordinate where we have autonomous agents, and how do we bring about this coordination, and the existing literature on it. So the first paper was Too Many Cooks, Bayesian Inference for Coordinating Multi-Agent Collaboration. This is the one that had a complete reinforcement learning base for creating each individual agent, where it used a Markov decision process. And then to make them collaborate, it has this really clever probabilistic approach where basically I think this figure explains it really well, where like each agent kind of so the to achieve coordination, there are these tasks and subtasks, and what they tried to do was break down each subtask into, like, either the agents can do them on their own or they can collaborate and do them join. And the way the probabilistic approach worked was they kind of had similar formulas. They didn't know what the other agent was working on, which is why there was no prior information, and each agent kind of tried to estimate a probability of, like, itself doing it, the other agent doing it, or the both of them doing it together. So these are what these three colors kind of represent. And the way it worked out in all of these subtasks is because of the mathematical calculation being based on the same shared history. They were both like the probabilities, each individual agent calculated around the same probability, which is why they were able to coordinate, because they were able to guess that this is a task that we should collaborate on and this is a task we should do earlier. So the two main things that I got from this paper was the fact about using belief states, which is the probability part, which is what it believes that the other agents are doing, and the shared history part, where, like, it is what they have observed in the past, they kind of store, and that is what they use to calculate the likelihood of, like, further actions. And then the next two papers were like papers that I had kind of researched on my own that I don't think anyone here would be previously familiar with. The first one is this chat dev paper. The actual title is Communicative Agents for Software Development. This paper uses multi-agents where each agent is powered by a large language model to create an entire software company consisting of CEOs, CTOs, all the way down to actual programmers who write actual code that can then, in the end, run as a complete system. And again, so now, like when I read this paper after reading the reinforcement learning paper, I started noticing many similarities. The first thing that was like unique about this paper was the way it used the waterfall model, something very commonly used in software development lifecycle, and kind of made that as the stages for all of this. But the next similar thing that I found was the memory stream, or like the earlier paper used this concept of shared history for each agent to kind of guess or estimate what the other agents were doing. So this was similar in both. And then obviously there were some unique things about why they used LLMs, and this is also similar to why I think we like our approach for going from reinforcement learning to LLMs will be very similar, because when you come to this point of shared history, in reinforcement learning, that history is just in the form is just in the form of parameters and numerical models. But when we have LLMs come into the picture, when we give them shared history, we can actually give them actual context, and that can affect their dialogue and behavior generation. And hallucinations is just something of why we go from one LLM to multiple LLMs, because they can sort of correct each other. And adaptability is definitely a huge plus in LLMs as well, where they can adapt. Like here, they were told that you can code. So this is also something where in LLMs, both the LLMs papers have this start of when they define an agent, they just kind of define a role for it and tell it that you are supposed to be this, you are supposed to be a programmer, you are supposed to be a CPU. And that affects its entire life cycle. And the third paper is what like I think would be quite important for our like whatever plan to base our entire open source community sustainability project on for the LLM approach, which is humanoid agents. It is a platform for simulating human-like generative agents. I mentioned this paper both in my proposal as well in my earlier presentation. So I'll just go through it quickly, but kind of the base of this paper is how similar to the first paper where it created these belief states. This paper also comes up with something called internal states. These are these various metrics of each agent, where like it can have its self-esteem or actualization, or even actual metrics like happiness, safety, physiological health, etc. And then based on its relationships with other agents, that LLMs can simulate very nicely because of their natural language, where agents can actually talk to each other and they can build up on their relationship like that. These internal states are updated throughout. So basic needs and emotions and more. And then of course the dialogue and the discourse and the personality traits, all of these have an effect on how these internal states are updated. So this is again something that I found similar to the first paper, where just the only difference is in the first paper everything was mathematics and everything was numbers when it came to parameters, and here you could have actual, like you could say that an agent was this happy and now it had this conversation which was sad, so now its happiness decreased, which was possible because of LLMs. So yeah, I'll post this and I'll share the link as well for the Medium and the self-posted blog soon. But the main takeaway for me, like as I start my coding journey now, was to kind of build up on all three of these and also incorporate this. Like I think the first thing that I'll need to do for our project is come up with a final kind of our metrics, or what our belief states or what our internal states would be, So I do remember in the earlier discussion there was some discussion about a moonshot or goal shot goals as a measure of sustainability, and also some things that I had thought of on my own as like code quality or GitHub stats also being a measure of the overall community sustainability. But I would also need to model each agent's individual perspectives, like their internal belief states. And so I think this is like one of my next tasks to do. And if anyone has any literature, I plan to do my own research too, of course. But if anyone has any literature which is specifically about how the psychology of people within like open source or volunteer communities works, and what are some kind of metrics we could impose there, that would be really helpful. So this is one. I see some questions in the chat. I'll address those. The belief states similar to Viterbi algorithm states. I'm not very familiar with the Viterbi algorithm, but the belief states in the first paper are done completely on the Bayes, like they are based on the Bayes rule or the prior probability, where it is such that the this is every agent knows has some prior given probability based on its observations of the other agents, and then based on that it calculates the next probability based on the given probability. So I don't know that it is based on the Bayes rule of probability. Yeah, thank you for the GitHub as well. Another thing that I wanted to kind of mention, I'll take any questions for this. It's just another thing that I wanted to mention. So the official coding period for GSoC starts from 27th, but unfortunately I also have my finals week of university starting from the same week. So my initial timeline, my plan for the first week was to kind of set up the frameworks that I would be using. I have some candidates for it in mind. There is something called MetaGPT and another framework called OpenAGI. And the codes of humanoid agents and Chatter, both that are also open source. So I was planning on looking at it and setting up an initial framework and getting it to work with an open source large language model, since I don't think using the OpenAI's GPT API would be feasible. So I was wondering if it was possible that if I could begin this work a little early in the next week itself, so that I don't fall behind in my schedule during the actual coding period.
Yeah, I think you can start now. I mean, as long as you know kind of where you're going, so that's fine. Thank you. Yeah, thank you for that.
I had a question really quickly.
Yeah.
Oh, sorry. Thanks.
Go ahead.
The data that you're presenting right now. So it looks like you're comparing belief states and the probabilities across different actions for each agent. Is it meant to be so sparse? At least this data right now. I am just looking at the. Okay. Yeah.
Yeah, I'll address. That's actually a great question. I mentioned it in the blog, but the way this the test suite that they had for this was sort of cooking, where they based it on this game called Overcooked, and they had this like all of this is basically there's a recipe to make salad, and it goes from merging chopping lettuce and putting it somewhere, all the way to getting all the ingredients together on a plate.
Oh wow!
And the reason it is reason it is so sparse is they've divided this main task of creating a salad into different subtasks. Each of this is a subtask, and they actually there is a precondition for each task. Like you can only put the tomato into a plate after it was chopped. So because of that, until these preconditions are met, the probability will be zero, because there is no way for the agent to even think of doing that task. It is not possible to do. And so even because of this data being sparse, the reward states also become sparse. And the paper actually mentions this as well, that because of this, there is like they have a discount factor that handles the reward function being sparse. I hope that answers the question.
Okay, like I would like to say two things. So basically, like you talked about the issues like moonshot, outshot issues. In our like GSoC, we also had Brian's approach, who also used some kind of internal states in his model, like if I remember correctly, like the active inference model. So maybe you can go and look at that. Second thing, like about the psychology of open source sustainability, I think like Bradley had shared a Google Drive. Like he did it like in when I was doing GSoC. It had a lot of papers and basically a lot of things related to open source sustainability, along with a different reading groups, papers. So maybe if Bradley can share them, that would be great. And it also has a lot of like psychology in open source as well as different like there was I remember very clearly there was like a book or like a small book about licensing in open source, and that also had a lot of you could say examples wherein like how the licensing works, like how the GPA license and the MIT license differ, and that was also one point of consideration that we had in our like literature review.
Alright, that would be great. I'm sorry if I've missed the drive if it was shared earlier.
Oh no, I think that's something I'm going to do in a little bit here. So.
Alright, sure.
Yeah.
Thanks
Okay.
a lot.
Well, yeah, thank you. Yeah, and Himanshu, of course, has gone through this process of, we did this with the reinforcement learning models for Himanshu. So, that's something that you can share insights on in terms of like how do you quantify some of these problems, especially with respect to the different types of sizes of contribution, because Himanshu did that for his reinforcement learning model. So I think that's, I don't want to reinvent the wheel there, but I also don't want to miss out on that sort of process. I can't remember myself what we talked about, and probably Himanshu doesn't either, but like, we can kind of resurrect some of those ideas and see, where they can go with this kind of model, because this is a different type of approach. So yeah, I think that's great. So yeah, I'm looking forward, to you getting started, and it's great.
Sure. Thank you.
You're welcome. So, anyone else want to give an update? I know we have people from both the orthogonal lab, but also at the DevoWorm group. We have Pakhi, and I think Mehul was here. But did we have any updates for that?
So I briefly mentioned, okay, if other people need to present, they can. But there was one other project I meant to give an update on that I forgot.
Go ahead.
So, okay, I'll just go ahead. Yeah. So I've been working under Dr. Richard Gordon on a breast cancer computed tomography approach. Excuse me, on a very, very, very different project involving taking advantage of providing a more efficient, effective way for screening and detecting breast cancer. This is under Dick Gordon. So, like, technically it's part of DevoWorm, but it's not really using anything related to, like, OpenWorm, DevoWorm. We're working on it independently. And just wanted to give some brief updates because we are looking for someone who has expertise in Monte Carlo simulations. Basically, overall, this project is meant to enhance tumor detection technologies with some of the more efficient, effective ways of computing. And it's involving a lot of stuff involving 2D imaging. 3D imaging, we use Blender in Unity, which is really cool because everyone uses Blender for making donuts, but you can also use it for scientific. Sorry. So for those of you who are not familiar, Blender is a 3D software, ultimately about art and animation. So if you're into like drawing, you're into like creating things and cartoons, that's cool. but you use it for a lot of different stuff that involves 3D work, like simulations, reinforcement learning with agents. People use for animation technology with science as well. And we're going to be using it for simulating X-rays, and seeing how the in the context of polycapillary screening, polycapillary optics for breast cancer. So under Dr. Richard Gordon, who's a theoretical physicist, or excuse me, a theoretical biologist, who has a background like in physics and has dabbled into chemical physics as well too. He basically is thrusting a lot of problems onto me, which require a lot of work from the background of chemical physics, optics, in enhancing computed tomography screening to make breast cancer screening more efficient, more effective, safer, because you'll have to rely on fewer resources for people in general. And ultimately, we plan, if we can get this together by the end of the year, on patenting the technology altogether, all right? So if anyone here has interest or expertise in machine learning and ML and thinks they can contribute, feel free to reach out to me. I'm on the Slack channels for Oral and for OpenWorm, so if anybody's like doing OpenWorm, DevOrm technology. And, some of the more tangible products in place could include book chapters, potential paper co-authors, and ownership and things like that. So, just feel free to reach out. It's pretty exciting work. So, yeah. Oh, yeah, Blender using it for 3D 3D animation and stuff. There's a very popular tutorial on how to make a donut in Blender. And people use it as that's everyone's introduction to Blender. So anytime you talk about using Blender, it's like, oh cool, did you make the donut? It's become commonplace, the donut tutorial. So
yeah.
That's where donuts come into play. We are not making donuts. We are studying breast cancer. We're improving breast cancer detection technology. So we'll see where things go. Thanks.
I had two questions. How exactly is Blender being used for the modeling part?
So right now, the simulation technology needs to take advantage of 3D space for actually capturing the surface, the geometry of the spheres that we're using. We use this. Let me see if I can find a quick link to this. Okay, take a look at this link to Janus or Janus particles I just posted there. Yeah, you see that?
Mm-hmm.
A special type of microparticles with a distinct form of chemistry, and you can model them in 3D using Blender, and actually use the properties of surfaces and meshes to simulate the actual chemical structures of the Janus or Janus spheres themselves. So we're actually using Blender for simulating the ways the X-rays interact across the Blender surfaces themselves in 3D technology and 3D space. Yeah, that's where Blender comes into play.
What is the machine learning aspect of the project right now? And I think there'll be some more CV-based approaches as well. I remember Dr. Richard talking about image and painting as well during his approach in DevOrm.
Yeah. So more specifically, there's an algorithm. Excuse me. Okay, with breast cancer, the RCT domain, there are these different proteins related to the BRCA. Excuse me. There's a specific algorithm we're using that is being optimized with respect to the breast cancer detection. As we figure out the best ways to sort out tumors we find, and figuring out which tumors may require surgery or which ones might not, we want to figure out the best ways to detect tumors, and that involves being able to see how these X-rays specifically hit off, bounce off, and interact with the actual images of the breast, the actual breast cancers, the actual skin themselves on their surfaces. What sort of technology, what sort of computational tools are involved as breast cancer is potentially being detected from the tumors themselves? Okay, so this is essentially a problem involving pre-processing of images, having a training set and a testing set, being able to train the images that are augmented versus the images that are segmented, and post processing. Like Bradley had originally been working on, if you were wanting to talk about the problem of Perlin noise.
Oh yeah.
Remember? Yeah, Perlin noise. We wanted, like, for example, from Bradley's perspective, we wanted to know, excuse me, how medical imaging, when we're modeling the human anatomy, how we can scale or use Perlin noise, for example, to simulate the anatomical structures of the breast tissue itself. So from a machine learning approach, from an AI or machine learning approach, there are these problems and questions and issues of difficulty of optimizing using like atom optimizer, cross entropy loss, okay? When decoding, yeah? What convolutional layers and stages would be involved in the neural network itself, okay? So yeah, that's where we're coming at. And so I hope the problem doesn't sound too broad, because you might think like even for me, I don't have a chemical physics background. My background is in physics, and I did take some courses in like stat mech and optics and stuff, but I'm not like a chem major. So a lot of things in terms of like molecular patterns of the geometry of the actual breast cancer tissues themselves, I'm like, I'm not so familiar with that. But these are all things that, if you have a science mindset, you got a quantitative background, you want to delve into something very, very thorough and practical applications, and potentially be on board with patented technology. We're actually speaking with best ways to market this eventually too. Reach out to me. I hope that answers your question, because I don't mean to sound too broad. I really don't mean to sound too broad, because it is a very big problem. But it is essentially rooted in machine learning approaches to breast cancer detection from CT, computed tomography. So yeah.
No, I think that's good. I mean, there are a lot of questions there, and I think one of Richard's big goals is to have, to work on this method and sort of the things that come out of it. I mean, basically, in a case like that, you want to have like a demo or two where you can demonstrate the principle, and so it's always about managing the different things that kind of come out of that, the different questions that come out of the technique that you're working with.
Yeah, absolutely. And even from a more like practical social perspective, Dr. Gordon and I, he's the scientist I'm working with, Dr. Richard Gordon. Him and I, we do have regular discussions on how this fits into the broader picture of society as well as a whole. Like, say, even like breast cancer research, breast cancer supports. How does this relate and compete against current technologies of detection that people have to deal with on a daily basis? And we need to thoroughly show that this is a much more improved approach, that this is well on board with getting involved with, and we as ourselves can improve the detection for breast cancer detection. So and there are very specific algorithms we're looking at. I'm happy to elaborate on the algorithms themselves, whether they're involved in the Janosphere particle detection. And I'm very happy to elaborate on what software we're specifically using. I just really love Blender, and I think Blender is the best one for this. I'm not just saying that out of personal bias. There are other 3D programs too, like Maya, Unity. Blender is probably the best for these. Okay, maybe Unreal. We actually did suggest Unreal as well. For any of you guys who know about these 3D software, right? But Blender's really good too. So we'll see how things go. Yeah, you actually like physically draw the sphere, and you you gotta sort out different chemical properties and textures. So it's not just making it look pretty from like an artistic point of view. This is actually scientific. Yeah, I think that's really cool. Not just making donuts.
Yeah, that's great. So thank you, Hussain, for that update. So I don't know if Morgan or Jesse had anything to add. I know that Jesse sometimes has something he wants to go into in an impromptu way.
I think there's been a lot of things said so far today, so I don't think I'm going to rush into anything right now. If anything, I'll just say I think Jen's been in a meeting before. Not one of these meetings, but like a Saturday meeting or some other meeting, but just appreciate Jen being here. Jen has a background in training and some adult education things, and sort of doing helping with onboarding for this and all other projects for both the lab and also JoPro stuff too. So sort of administrative support and maybe curriculum development kinds of things that could help us in sort of the pedagogical education sense. So I invited her here today kind of on short notice, just to kind of get a sense for us. And like Jen already knows that we're quite an unwieldy bunch, and we have things come up and things aren't organized. So at times, but just to help with that and help. We're kind of putting together like a frequently asked questions page for. I'll show that. I'll show that for like Google Summer of Code stuff. If I have it open, actually, I might not have it open. Yeah, I'll share it later. But we're putting together sort of like a Notion hub that can be like a page, just like a central resource for people. Like Sarah kind of was like, oh, could I share this to Medium? And the answer I think is yes. Like we really encourage you to make a post for your own website, however you want to do it, but also share it, cross post here. Like, we really want to encourage those sorts of things, and I think maybe not quite a syllabus, but having some materials that are structured and thoughtful. And we have actually a ton of great content, like the thing that Himanshu mentioned, the things that I posted something in Slack that was like an introduction from 2 years ago for open house stuff about Google Summer. Like, so just organizing it and making it a little bit more user friendly to access is kind of what we're working on. I don't know if Jen wants to like say hi or say anything else, but you know, that's why I invited her to this meeting, just to kind of see the chaos and hopefully work on building out some other things. I'm glad that she's here. So.
Yeah. Well, welcome, Jen, and thank you, Jesse, for the update. Did Morgan want to say something? I know he was.
No. Yeah, just love to see the project overviews, or catching up with blog posts. If people have blog posts or things that just kind of summarize what they'll be working on, I'd love to see that. And and you can always get in touch with anything that might be of interest that you see on Slack or on the other platforms that we're on.
Yeah, so Morgan, of course, has experience with a lot of open source things in the neuroscience area and some of the neurotech and stuff like that. So definitely reach out if you're interested in that area. Yeah. Okay, so if there are no more updates, I'm going to go into some materials that I have. And like we talked about, we have some reading materials that are going to be of interest to people, and some other resources that we have as well on GitHub. Let me share my screen. All right, so the first thing I'm going to talk about is this open science and open source repository. This is on Google Drive. So these are readings that I've collected. One set of the readings are on sort of career development things for open source. So we have like communities and collaboration. I have some references here. Just some cursory references. These are things that you can get a taste of here and then go find out more on the internet. Do your own research, as they say. Innovation, which is about, how do you foster innovation? There's a lot of stuff here on designing your own doctoral project. This article, Golden Eggs Make Better Telescopes, which is about, investing in innovation and things like that. And so I have a lot of things here on that topic. Then there's this licensing. This is what Himanshu was referring to. This is an article by Ryan Merkley. I think I don't know if he's still on the Open Room board, but he's done this stuff on, and there are a lot of resources on this. And I have a section in my project management course that talks about open source licensing. So, we have the Creative Commons licenses and we have the software specific licenses. So, I can put some of those slides in this repository as well. But Ryan wrote an article here on licensing creative work and how attribution is gratitude. And so it's really about, using licenses to license open source materials, whether they be software or course content or, YouTube videos or whatever, having the appropriate license. And then there's an economy that you can sometimes make money off of, but there's also this reputational economy, the sharing economy, and it's a bit deeper than just simply, cashing a check or getting royalties. And in fact, that's, one of the things that you have to sort of master to do effective open source is how do you manage your licensing? How do you manage the terms of reuse? How do you enforce those things so that people will either attribute you or, you don't sort of put your best stuff behind a paywall, but then that also excludes you from being able to share these things and work out, things in different forks. So there's a balance there. This is new types of institutions. So the orthogonal lab is sort of a distributed collaborative research institution. This is a collection of readings that I've been putting together on some of these new types of institutions and the aspects behind them. This is open data, which of course, if you're working with open source software, you're going to encounter open data sets and how those are licensed and reused. This talks about the FAIR standards. I really, haven't updated these repositories in a while, so I may update them, but I think this gives you a good taste of some of these topics. Social media facilitates openness, working open and together. That is, how do you work in a collaborative way, working in an open source, in the spirit of open source. So how do you work, say, in the kinds of meetings we have here, virtual meetings? How do you leverage those to make those worth your while? And then how do you translate that into creating open source artifacts and collaborative artifacts? So again, all these readings are, for you, for whatever you're interested in. Please take a look at those. I'll put the link in the Slack. And, if you have questions, maybe you can raise them in next week's meeting or, in a subsequent meeting. Then I have these 4 resources down here, 3 PDFs and a PowerPoint. So I have a couple of readings on sort of open source software and the practice of producing open source software and open source software-based projects. So this book is Producing Open Source Software, How to Run a Successful Free Software Project. And there's this thing called FOSS, which is Free and Open Source Software. It's an acronym. And that's an approach to open source where, there's an imperative to have free software, an imperative to be open source, and, how do you manage that? How do you maintain sustainability? How do you manage contributions? How do you manage the sort of aspects of keeping the software going, keeping the organization going? So this is very valuable, not necessarily for your projects in GSoC, but if you're interested in this idea of if you have a project and it's successful, how do you scale it up? How do you sustain it? How do you make sure that you retain your values around free and open source, but also be able to maintain the organization? It's got some really good things that I'm not going to get into some of these, but it kind of talks about the history of open source software and some of the challenges and how you might go about some of these things. They do things like differentiate between users and developers and give you a sense of how those things work in an organization. This book is on open science, so this is, but it's called Open, so it's not just relevant to open science. Basically, this book is open, the philosophy that practices that are revolutionizing education and science. So this is not just about open science, it's about open education, it's about this open ethos that we're building and that is championed through GSoC. So we have a lot of things here in this book. We have some things on open licensing and open education licensing policy. So, some of your projects, of course, are on GitHub. You might use, people might use them to do things with open source communities or simulate things, or there might be machine learning techniques. But sometimes we're interested in, these sort of open education projects, which are a little bit different. And, depending on what the use case is for the project that you're making or the software that you're making through the project, it's going to have different rules and you're going to have to consider different things. So, if you have an open source license, say like you pick a software license and you really have a lot of content that's, things that aren't software, that's not a good fit because there are a lot of things that aren't going to be covered in a software license, that are integral to the project. So, for example, if you have course content, or if you have videos, or if you have other types of things that you need to manage, and you can't do it with just a simple software license. So there are a lot of things, a lot of regulatory agencies that you might have to go through. With open education, you may have to deal with accreditation. You may need to deal with, interfacing with traditional educational institutions, things like that. And so there are a lot of challenges that, we have in open source licensing and in different types of open source projects. And so this just kind of goes through a lot of these things about open. There's open practices. So we have methodologies for doing things like opening science, having open science. There are different protocols. There are different standards that people use, and there are different practices, like pre-printing, opening up a data set, pre-registering scientific studies and things like that. This one is open course development. So, when you're building course content, there is sort of a traditional way to do it, but then there's also this open way to do it, which means that you have this open aspect in mind when you start designing the course. And their topics here, like opening up higher education with screencasts. So they're very specific things. Some of these are sort of pre-pandemic and as such are maybe a little bit dated. So that's a caveat here. So this is all a fast-moving area. And so I would use this book as maybe a baseline, and I would, go out and see if there are newer approaches to this stuff. But it's just a good survey of a lot of things that you can do in this open source space. This is a book for data scientists, but I include this because we do have a data science component to the orthogonal web and for DivaWorm particularly, which kind of goes through data science and working with data. And so this is the field guide to data science. This gives you some highlights of how to do data science, how to think about data. There are all sorts of things like storytelling and creating graphs and things like that they cover in here. So, these are things that they're not for everyone. Everyone has their own interests, but I've tried to accumulate a sort of a representative sample here. Then I have this laboratory contribution philosophy. I won't open that up right now, but this is a presentation I give on sort of how we view laboratory contributions in the group. And if you've attended the Saturday meetings or you attended the DivaWorm meetings, you've gotten a small taste of that with some of the things we do. But we have this deeper philosophy on laboratory contributions, including how we view like contributions to a project. You don't have to sort of start at the end. In other words, you don't have to produce this huge artifact to be considered a contributor or to even sort of take a first step at putting things out in the world. And in fact, we champion an approach where you take small steps and you produce things like blog posts and laboratory notebook entries and things like that, or presentations. And then you move up from there. And all those things kind of work together to give you that artifact that you can then put out into the world. So it could be like a software repository, it could be a paper or something else. But you have to start at the smaller units and get those out there. And if you've done those things, then that makes the bigger things easier. So there are a lot of good things in here if you're interested in sort of the contribution philosophy of the group historically and sort of in practice when you're building a project. Yeah, go ahead.
There's a bunch of things there, and I think you saw more you wanted to say, so I don't want to necessarily interrupt too much, but I'll say there's I think 1 year I did a how-to ORL, how to it was called how to do orthogonal lab stuff, and I know that we've had presentations on YouTube for that, and I think one of the things that Dan and I are going to try to do is basically make a web document or maybe not a PDF, but sort of a Notion page or something that will take you through it and list those things out. To that end, having Bradley's mentioned a bunch of books, but kind of maybe saying, you may want to pay attention to this part of the open book about whatever. I think there's a way we can take those resources and make them a little bit more accessible. And we have so much content.
Yeah.
It's just how do we unbury it and make it somewhat interpretable.
Yeah.
So yeah. I think you had more you wanted to say before other stuff.
Well, yeah, in terms of onboarding, we have the onboarding materials, and part of what we were meeting about earlier was, we need to kind of unify all our onboarding materials. So a case in point is this thing here, this is on the ORL group GitHub, and this is kind of an onboarding guide that we've used in the past. This is a general onboarding guide, not just specifically for GSoC. But it kind of goes through sort of a front door to the lab. So, this is we have an onboarding repository, intro to ORL. This is a markdown file, and we have these links. So I created a preprint a while back. It's available, and you can read through it. I need to update it, but it's basically talking about the structure of the lab and how it's unique and how we can leverage it for education and open source and things like that. We also have a YouTube channel and a lab medium, and then we're developing this onboarding guide, which is a link to, I don't like it when things get recursively linked. Actually, this is not recursively linked. This is linked to something else, which is no longer there. So we need to fix that. But this is, we'll be developing this onboarding guide for GSoC. And then this is just an introductory presentation to the lab. So this is this preprint distributed enabling computational laboratory, kind of talking about some of the things that we do in terms of mentorship, education, open source research, what we call an alt-academic institution. An explanation of why we call it the orthogonal lab here. It's sort of the idea that it's interdisciplinary and that those fields meet at sort of right angles, and we kind of explore the space in between there. And, and then we kind of talk about coordination via sort of the way messages, meetings, and ideation, document sharing, open publishing, and then, we have models for this where we kind of have a pipeline where we work through. We start with a very small idea, we grab that idea, we develop it, we make bigger artifacts, and then we put together, a project. It might be a paper, it might be a couple of presentations, but to facilitate all of that. I have some slides on the effects of the pandemic and some examples of some people who have contributed to the lab, just showing the diversity of people and what their interests are. And then synergies between research interest groups, and so it goes on and on. And so that's some of the materials we have for general onboarding. Again, we're going to fix the onboarding materials. We're going to revise them as we should, because some of these things get out of date. The last thing I want to talk about today are the repositories that we have that are open source on GitHub. So we have this ORL group GitHub, which is where we're going to host the GSoC things for the orthogonal lab, and for the DevoLearn group, we're going to be hosting them on a different repository. So I don't want to make you think that you're gonna all be in the same place, but we'll sort that out specific to the people who are going to be working on things. But I wanted to point this out because we have a lot of things here. We have a lot of forks of things, but we also have a lot of repositories that might be of interest to people. So Saturday Morning NeuroSim, which is our Saturday meeting, has its own repository. We have this VRDR, which is for the virtual reality projects. Last summer's GSoC is in here, and I think Adama will be contributing to this as well because she's working on some things of virtual reality. So we have this virtual reality repository. We also have some other things here. We have, this is the DevoLearn organization, which we will this is actually a fork of DevoLearn, and I'll also fork DevoLearn, DevoGraph, which is where the two DevoWorm students are going to be contributing to. So we'll have, the forks that'll be synchronized, and we'll have the repositories that you'll contribute to. So you'll be contributing directly to the repository this year. And I expect weekly updates to those repositories. We have other things like MetaBrain models, the open house that we have had in the past. And so we have a lot of different things. We have our work on developmental Bradenburg vehicles, which is a lot of the stuff we've done with agent-based modeling and Bradenburg vehicles. This is a more cognitive science, computational neuroscience type project. But we have these things where, like, past years' GSoC projects have been sort of, put into a repository that then is open for people to work on. And, we can do, subsequent years' GSoC projects. We can do, open source projects with anyone who wants to work on something. We have other types of repositories here. This is just, a sampling of what kind of our activities on GitHub and our sort of standards for contributing to things in the organization. So you can contribute to things on GitHub, or you sometimes contribute to things in other ways. But that's one pathway to contribution. And of course, we have our Medium, we have our YouTube channel, we have our meetings. And so all those are ways to contribute to the organization. Okay, so any other words before we go? Any other comments?
Hi, hello everyone. Sorry I couldn't speak in the beginning. I was settling down. I got a bit late from college today. So I just wanted to share my update. I actually went through the DevoLearn repository, and I found some models there, like the membrane segmentation and the centroid location model. So I was planning of just starting to use them to locate the centroids and then find the distance between them to use them as edge weights in the graph networks. And I was also going through this paper on growing neural networks, where I will share the link in the chat. So basically in this paper they are actually using this technique called GradMax, where they maximize the gradients of new weights instead of, with the help of this, they don't impact the already trained nodes in the graphs sort of. So I thought this would be useful for our growing graphs that I'm planning to implement. So I'm just looking at resources for now and going through the code base in DevoLearn and DevoGraph repositories and figuring out how to use them.
Okay. Yeah, I would suggest that's, if you're interested in a project, that's the way to do it. I mean, go through the code base. And of course, we'll be, when we start the coding period, and Sarah's already starting, but I'll set up the GitHub repositories for each person or tell you how I want you to contribute, so we can keep, we can come to the meetings, we can go to that repository, say this is where I put my contributions, and then talk about some of those things. And if you don't have any code for that week, it's fine. Just make sure that you keep everything up to date in those repositories.
That was basically going to be my. I'll just put it in the chat, but it's kind of outdated to this. So yeah, like it was going to be, are we going to be in terms of like making issues and project boards and stuff again, like we have in the past? Like I think that's sort of what we want to do, but I don't know. In the past, we'd like bring up the issues in the project board and say, okay, did we do this week, or where are we with this? And is that kind of what we want to do this year again?
We could do that. Yeah, we should set up a project board. I would think, for DevoLearn, it would be like in DevoGraph, we'll have a project board there. In Orthogonal Lab, we might, because you can create project boards at the org level. So we might have at the org level a project board for GSoC.
Yeah. Just so people like realize, like if you're so inclined, or if you need invites to the orgs or something too, I don't know if Bradley's done that or will be doing that, but I can assist with getting that too. You can make your own. You can do whatever you want for your own repos or board, but we'll also have these sort of like macro level boards, just to kind of for all of us during the meetings to go through. Okay, here we are. Here's an issue kind of at the broader level. That may just kind of think, oh, let's check on this next week. Do we move this forward, or do we need to, make sure talk to this mentor or look at this past thing, just to sort of like do the project management work at our meetings. But you can also do them like your own stuff your own way. But I guess Bradley will be making those the internal to the lab repos and inviting you like the next week or so.
Yeah, I'll do that.
Fair? Okay. And I can help with that too.
Yeah.
But just because what we would like to try to do with going back to Jen and the onboarding stuff is like kind of hopefully hand out sort of a, hey, here's all this stuff, like a checklist of make sure you have your repo, make sure you're in Slack, make sure you have this stuff, and just give the people like a sort of, hey, do you have all the little details that you need, kind of a thing. So that's cool. I think that makes sense, and I'm looking forward to all that. And let me know. I'll probably mention to Bradley and Jen after this or over the weekend to kind of recap from what we need to do or regroup. But I think we're on the right track.
Yeah.
So yeah.
All right. Well, thank you for attending the meeting, and remember, we'll have this meeting weekly. And keep up the good work, and look forward to your updates. Thank you. Bye.
All right. Take care, everybody.
Take care. Bye.
Thank you.
Thank you.
Thank you.
Yeah, thank you. Bye.